going to talk now about one of my favorite subjects, which is chromatic aberration. I have seen this so many times in the field and being so misunderstood. Like, you know, I see these edges, I see blue edges on the subject, when it really is caused by chromatic aberration. This is not necessarily a defect of the lens, but when we push the camera to extremes, like a very bright object over a dark background, we tend to create aberrations. Like in this case, if you take my forehead on this side here against a black background like I have behind me, if the lens would have aberration, you would see a blue halo or blue edge here if the image is overexposed. Of course, this camera here does not have has a better lens, a more expensive lens, which compensates for the aberration. So what is it, in fact, that causes this? Because the red, green, and blue have different wavelengths, as they pass through the glass, they pass at different speeds, and the focal length is slightly different. So if you have a red-colored object, the wavelength is longer. Therefore, the focal length will be longer, as compared to a blue object, which has a shorter wavelength and a shorter focal length. So when the object is white, like my forehead is now exposed here, it will contain all those colors. But at the transition, the blue will be out of focus, providing a thicker edge, and it will show as a aberration or as a blue line. Chromatic aberration on this chart is visible on these squares where you see the blue edge and the red edge. The result is like this because the focal length of the red, green, and blue are not coincidental. In the case of 3-chip cameras or 3 imagers, either CCDs or CMOS, when we do this, the lens that is used is actually required to have chromatic aberration. You will say, how so? You know, I thought we didn't want to have any aberration. Well, as I said before, sometimes aberration is wanted, like in this case, where the light separation, the color separation takes place in a prism, and the focal length for the red and the green and the blue are actually different. Therefore, the lens must have a built-in aberration to compensate so that the focal length, so that the image on each one of the sensors is properly focused. Now, I challenge you, if you don't understand this, send us an email or contact us, and we'll open this for discussion.